So even if no harm comes to a particular person, so for example, even if I am not, say, negatively impacted, maybe I'm never detained by the police or wrongly identified, we can still see that something is seemingly gone wrong here.
Sometimes the effective function of the use of AI can be to focus attention on the technology and away from how it's used, by whom, and to what ends. The ethical considerations don't start at the point after you've deployed the system and now you're seeing some results. The ethical considerations ought to come early on, and so no one can hide behind their hand and say, oh, I didn't see this coming.
From the College of Engineering at Oregon State University, this is Engineering Out Loud. Hi, everyone. I'm Rachel Robertson. Today on Engineering Out Loud, you will hear more from Alicia Patterson and Houssam Abbas. They are both assistant professors at Oregon State University studying ethics in AI, but from very different perspectives. Alicia has her PhD in philosophy, and her research focuses on the ethics of emerging technology, especially privacy and data ethics. Houssam has a PhD in electrical engineering, and his research interests are in verification and control of cyber-physical systems and formal ethical theories for autonomous agents, like unpiloted ground and aerial vehicles. This recording is from a talk entitled, "Where Do Ethics Belong in Artificial Intelligence?" They designed this talk for a general audience for a presentation at OMSI, the Oregon Museum of Science and Industry. This is a recording from a talk at Oregon State University. Now enjoy a deep dive into how philosophers and engineers are thinking about ethics in artificial intelligence.
Where do ethics belong in artificial intelligence? So start with a story, and the story begins in the 1950s in the psychiatric ward of Bellevue Hospital in New York, where Bill McPhee was committed. While committed there, he developed his idea for a voter prediction machine. The point of it was, and here I quote from Jill Lepore's book, If Then, How the Simulmatics Corporation Invented the Future. So the point of it was to create, literally, quote, a set of rules of thinking so that it is possible to reproduce or closely approximate the thinking behaviors of voters. Bill McPhee was then released from the psychiatric ward at Bellevue and finished his dissertation at Columbia University about a program to create a fully observable electorate. You would feed the machine massive amounts of microscopic data about users and issues, voters and issues, and it would be possible to assess the effect of any proposed course of action by a political candidate based on the likely reactions of the voters. Ed Greenfield, who was an ad man and was one of the key founders of the Simulmatics Corporation, which monetized the ideas of Bill McPhee and sold them, he put it like this. He said, suppose that a candidate was proposing to make a major civil rights speech in the South. Remember, this was the early 60s. We would be able, quote, through our model, to predict what the meaning of that speech to over 1,000 subgroups of a given population. And thus we would be able to predict the smallest percentage difference in votes, that is, that such a speech would have. The Simulmatics Corporation actually sold their services to the Kennedy campaign. Kennedy then went on to win the presidential election that year. Now, it is not clear how much influence they actually had because the recommendations that Simulmatics gave the campaign were largely seen to be common sense and would have been adopted anyway. But I think you can already see how that sort of foreshadows the general theme of user/voter/people prediction and then control. The Cambridge Analytica, they basically sold a more sophisticated version of what Simulmatics was trying to sell the Kennedy campaign to the Trump campaign in 2016 and to the Brexit Leave campaign in 2015. And the reason I start with this anecdote is to directly cut through to what perhaps is the biggest point of unease that some people might feel when they fret about AI and ethics, the notion that human behavior is predictable and then controllable. So in particular, most of you will probably have heard of the Facebook experiment on playing basically and controlling users' emotions based on what they bubble up in their feeds. Now, if users or people are predictable at least in the aggregate, and controllable, then why not program them into robots? And that then brings us to the notion of embodied intelligence, embodied artificial intelligence. One half of this is a humanoid of its own inventor. I'll give you a couple of seconds to try to guess which is the humanoid and which is the flesh and blood human. Right? This is the Geminoid DK by a Danish inventor whose name I now forget. Oh, it's in my notes, Henrik Scharf. Right? And so this reminds me of a famous, which I had on the slides and I removed, of a famous icon of Christ from the 6th century, which is supposed to portray the dual nature of Christ as man and God. It sounds our ambitions have now reduced to becoming man and machine. So hopefully this gives you sort of the corner cases, or some of the corner cases when discussing AI and ethics, in the way that they relate mostly to us, like the notion that we might be predictable and controllable. If you want to know what researchers are actually working on, you can literally pick up like any issue of the communications of the ACM from the last couple of years, and there will be an article in there about AI and ethics. Not ethics and CS in general, but specifically AI. From bias in credit rating to certain problems with computer vision systems, and so on and so forth. So rather than give a laundry list of that, I will hand it over to Alicia to help us think through a framework about these problems. Starting with a cautionary note that ethics is the hottest product in Silicon Valley's hype cycle today. So in order to step away from the hype and perhaps think about it more productively, Alicia.
Okay, so philosophers have a set of tools to think about ethical problems. That has been our bread and butter for forever, basically. And so we think maybe perhaps a little bit differently about how we spot ethical problems. So one of the key sort of concepts we have in philosophy are the concepts of a harm and a wrong. And we differentiate these because they sort of mean different things or pick out different types of ethical problems. So a harm is something that sets back your material interests. It makes you worse off, right? We might think of like suffering or something like that. So if someone steps on your foot, right, we can say they've harmed you because your foot now hurts and maybe it's swollen. A wrong, in contrast, is a sort of a violation of rights or some sort of disrespect of an important value or denying someone something they're owed, right? So if I say deny someone the right to vote, I've disrespected an important value and I've denied something they're owed, right, as a citizen, right? They're owed the right to vote. Perhaps, if the person is in not a swing state, their vote maybe doesn't make much of a difference. So maybe I didn't harm them very much, but we can still see that I've done something wrong to them, right? I've denied them something that they're owed. So harms and wrongs usually go together, but it's important to understand sort of their different contours to be able to fully map ethical problems. So some AI harms, when we originally made this wasn't such a big thing in the news, but Cigna, a health insurance company, uses algorithms, right, to sort of batch deny claims. And doctors are supposed to go through and review a patient's file, right, and see if the sort of medical claim is a medical necessity. And according to research by ProPublica, doctors were spending an average of 1.2 seconds on each case. I don't know about you, but I feel like I could speed read a little bit, but 1.2 seconds on a very serious medical decision seems pretty bad, right? So in this instance, we get an algorithm, right, that caused a particular kind of harm, right? It probably denied thousands of people certain procedures. That means patients, doctors, hospital staff have to do all of this extra labor to get the medical care that they deserve. And some people just might not be able to fully work the system and then give up and have to pay for things out of pocket. So here we can see the way in which this system made people worse off. It harmed them. In contrast, a wrong may not necessarily involve a concrete harm, right? So an example of this is the use of facial recognition by law enforcement. One of the sort of wrongs that we see is that people, a lot of times in AI systems, are treated sort of as mere data in large data sets. And data is scraped in mass from the internet, right? This is like all known to us. And there's no sort of regard for sort of fundamental values about how these people might want to be treated, right? In this instance, the value of privacy. So this is a really interesting read, if you want to check it out, put together by researchers at Georgetown. So researchers at Georgetown found that 1 in 2 Americans have their faces in data sets that are available to the police. And this is the exact kind of thing that we should worry about, right? That we're sort of infringing on important values like democratic freedoms or privacy. So even if no harm comes to a particular person, so for example, even if I am not, say, negatively impacted, maybe I'm never detained by the police or wrongly identified, we can still see that something is seemingly gone wrong here. So within the sort of scope of wrongs, injustice usually sits within it, because one of the things we want to pick out about injustice is that it's a certain form of disrespect. So when someone's committed an injustice, what value or what principle has been violated is the value or principle of fairness or equality. Oftentimes, injustice involves both a harm and a wrong, right? So you're treated unfairly and your life is made worse. So if you, say, are denied a promotion on, the basis of your race or gender, we can say, like, you're worse off. You don't have the income that you would have had, right? The career opportunities you would have had. But also, you've been disrespected, right? You've been treated in a way that you shouldn't have. So those are some ways. Actually, let me give an example of injustice first. So an example of injustice, there's too many to really even pick which one to talk about, but one example of automated bias, right, is in racial disparities in credit lending. A study by faculty in Stanford and University of Chicago looked into this, into sort of alternative models of credit scoring, and found that low income and minority groups were somewhere between 5 and 10% less likely to receive a loan than high income or non-minority groups. So here we can see, right, being denied a loan on the basis of your race is both wrong and you're harmed, right? You don't get the house and you're treated in a way that you should not have been treated. So this is sort of the background when we think about where is ethics coming into conversations in engineering and design. This is sort of my toy example of the design life cycle. Oftentimes, these sort of questions about ethics, about harms and wrongs and things like that, come in after a product has been designed, the research has been done in it for years, and it's either launched or about to be launched, and some problems are surfacing. And people ask questions about what sort of guardrails should be in place. And one of the problems with this is that it's sort of too little too late, right? When we ask questions about ethics, we should ask them from the very beginning, right? Because asking them from the beginning allows us to ask a series of questions about values through the entire design life cycle, through the entire research process, right? And that allows us to ask a broader set of questions rather than this narrow question of what sort of guardrail should we put in place? Or what sort of use cases should this be prohibited or encouraged for? So a variety of questions that we should ask are things like, before we even begin to develop this, is this technology the right solution to the problem at all? Science and technology scholars critique this question not being asked a lot, and they call this techno-solutionism, the idea that technology can be sort of the solution for these big social problems, that we're often not sitting back and saying, is this the right way to solve this problem? The next question that needs to be asked, and this is, I'll say I'm going through a series of questions, but this is by no means an exhaustive list. Does the community want the problem solved in this way? Whose input do we even have in thinking about what the problem is? So in design justice, sort of like a canon text in sort of intersection between ethics and design, people have this phrase of nothing for us without us, right? So do people who are impacted by the technology have any sort of meaningful ways to shape the values in design of it? The second, or third, I guess we're on third, we should we should look into the potential unforeseen consequences, again, before we've like created a product or we've put a ton of research into a certain type of algorithm, right? So feminist technology scholars, for example, often point out that like the first public adoption of a technology usually comes in the form of harm for women. So one example, there's many I could give you, is that when deepfakes were first like open source available to people on the internet, they were used en masse for non-consensual pornography or image-based sexual abuse. So here we can see like being the subject of pornography is something that women are significantly more likely to be subject to. And so we might have wanted the developers to have thought about that or grapple with that before they released this technology, right? So these are the sorts of things that maybe we can solve for or prevent for early on. We also might want to ask, is this technology compatible with important social goods like democratic values, right? When we are creating something that, say, involves a form of surveillance, we might want to understand, will this significantly impact, say, people's ability to freely assemble? Freedom of assembly is considered, say, a core democratic value, a value that you sort of, a right that you need to be able to express to be able to exist in a democracy at all. We also might want to ask, are we getting data in a way that it respects important rights? As I mentioned before, like a common practice in machine learning is just to do this mass web scraping. And we might want to ask a variety of questions about that, like, are we respecting people's right to, say, not participate in oppressive systems? Are we respecting their rights to privacy? We might also want to ask, are some people going to be more harmed by this than others, right? Maybe this question comes up the most when we're thinking about automating certain forms of labor. Who are the winners and losers? And who might be especially vulnerable to the impacts of a system? We want to ask questions about bias before a product is launched. We want to be able to grapple with that. We don't want something, as so often happens, something gets launched and then users who are negatively affected, who are of that group that the technology is biased against, are the ones being like, this doesn't work for us. This has happened again and again, right? So that's, again, something that we want to catch early and often. We want to ask, what are the potential misuses? For example, have we created a tool that's like really amazing, but also enables a lot of fraud? And lastly, then we can come to these questions about, say, guardrails. What sort of laws, regulation, policies, and norms need to be put in place to protect people or to ensure this sort of ethical use?
Thank you. So within that framework, or against the background of that framework, we can look at two major approaches so far in engineering to tackle the question of how does one, in a nutshell, program certain ethical norms or social norms more generally in engineering systems. This is a very high-level simplified view of that. One is utilitarianism, the other is non-utilitarianism, or as sometimes referred to as deontology. I'll start with deontology, from the Greek theon, duty, and logos for science or knowledge of. And whereas most of us probably think of the right thing to do is the thing that maximizes certain benefits, maximizes certain goods, deontology says, no, the way you assess whether there are certain moral norms that a moral agent ought to obey regardless of the consequences, regardless of the amount of good that that action produces or the amount of bad that that action leads to. So deontology is a normative theory regarding which choices are morally required, forbidden, or permitted. Those are three key categories. In contrast, for example, to moral theories which tell you what sort of person you ought to be, right? What makes a choice right is its conformity with a moral norm. So if we adopt such an approach, and that's sort of the perspective I take in my own research on algorithmic ethics, one then asks, how do we program duties into an AI agent? right? So if you have statements of which choices are morally required, forbidden, or permitted, can we think of them as design requirements for a subsystem of this overall system that we're trying to create? So you have your objective function, right? And this is the only math we're going to see, I think. You have your objective function. You want something to run fast, for example. And then you have those things that are permitted, forbidden, and required. And you express those in some mathematical formalism. And the idea is that once you've used these mathematical formalisms to express these two different things, and that's sort of the point I want to stress here, that the performance objectives are not the normative constraints. Magic, 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 it turns into zeros and ones, and then lo and behold, Cassie can run a 5K without kicking a rabbit on the way, right? So what is this mathematical formalism that allows us to express normative requirements? This, I think, most of us are or ought to be familiar with. We need basically a mathematical language that allows us to express such normative statements, which you and I can understand, because understanding is actually key here, right? An objective function with 1,000 parameters is not something you and I understand, or anybody, and whoever tells you that is probably fooling themselves and you. So we want something that you and I can understand, but which is also amenable to algorithmic, which is to say automatic or automated processing and reasoning. And the language most of us use is formal logic. You're all familiar with Boolean logic, but there's a zoo of logics out there, some of which are appropriate, or to some degree appropriate, for reasoning about normative statements. Once you do that, once you make that move, then reasoning becomes a calculation, right? The dream of Leibniz was that when there are disputes among persons, we can simply say, let us calculate, right? You run your argument, I run my argument, and the machine tells us, well, which argument is a sound argument, right? Does A follow from B? And so without further ado, we can see who is right. We're nowhere near that, obviously, but that's the overall idea. Now, formal methods and formal logic are heavily used for safety purposes, for designing safe systems, especially in safety-critical applications like avionics, for example, right? And in fact, in hardware. Any hardware company today makes heavy use of formal logic. But what we are talking about is using formal logics in order to formalize normative requirements, ethical and social requirements. There's some work I've done. There's work done by Matthias Scheutz at Tufts. Next week's AI seminar speaker, Adnan Darwish, also makes heavy use of formal logic for explainable AI in his case. And I think the center of gravity, really, of this sort of work still is in Europe, especially in Vienna. So if you're curious, you can look up that project that just launched, centered in Vienna, but with collaboration with Maryland. And the last thing I want to say here is that this formalism allows you to express and reason about normative requirements. It doesn't prevent you from doing performance optimization the way we usually do. The question is, how do you do the two together? So, you can still look at graphs. So, finally, it's good not to drink one's own Kool-Aid. Are there really rules that govern our thinking in general? Yes and no. You certainly cannot formalize all of the ways in which we actually think. Thinking is not always what we call rational thinking. It is still a different kind of thinking. So, The other form is utilitarianism. The other way of trying to program normative requirements is through utilitarianism, where you have, the good is a function of your actions. You have lots of optimizers that you throw at this mysterious function, and it gives you the best action, which is supposedly the most ethical action because it produces the most amount of good, right? It goes only so far, in my view, because those are, on some level, inherently incommensurate things, right? So let's take a very trivial example from this already old 2015 paper from Gerdes, right? So say you want the car to get to its destination, that's a performance objective. Without collisions, that's a normative requirement. Because a car can collide with someone and keep going, right? So it's not necessarily a performance requirement. While minimizing emissions, that's both performance and normative, because emissions are bad for people in general. So what does it mean to weigh all these? How do you weigh this? In meters? What sort of objective function are you going to put all of these in? What sort of reward function are you going to use in order to express all of these? Not to mention that sometimes ethical requirements is not something that you can choose more or less of. Sometimes you just have to do it, right? And so then you go into the multi-agent case, which complicates the picture. Nonetheless, there is, in fact, the AI alignment literature, most of it is on the side of, let's see how, is it possible to design, for example, a reward function for an RL agent such that it avoids catastrophic outcomes. Among that literature is reinforcement learning from human feedback, right? Where the idea is, suppose you want, for example, ChatGPT to produce the ethically normed answers. So what we do is we'll ask ChatGPT the same question 10 times. It's a stochastic machine. It will give us slightly different answers 10 times, and then we give it feedback on which one is the best, and this way it tweaks its own parameters. But now that you might say, okay, sounds reasonable, but then it's a market economy. So say, oh, are we really going to hire 1,000 people to do this 1,000 times? No. What do? We put another AI in there. So now you have an AI guiding another AI. Then you climb the AI ladder to nowhere. So I'm not going to pretend there's a good segue. We're just switching gears here. Right? The problem of responsibility in autonomous systems. There's two models of responsibility. Fully autonomous systems, which I'm not going to talk about because in my mind, there's no sense in which a fully autonomous machine is responsible for something when there's a human behind it. So we'll talk about, so I just swiped a whole bunch of things on the side. We'll talk about semi-autonomous systems, okay, workers in the loop. Now, usually humans in the loop is the terminology, but as Alicia was pointing out this morning, this is actually creating a whole new category of workers who have to watch terrible videos all day and so on and so forth. Now, you can have a worker in the loop for technical purposes, like radiologists as checking the AI radiology algorithms, and you can have them for legal and moral purposes. So even if this thing is great, you still need, for legal and moral purposes, for example, a lawyer in the loop, a lawyer in the war room. And I'll take an example from the Israeli army's use of AI for lethal targeting. So this is from March 2023, so before the latest war. From this article, several high-ranking IDF officers informed the press that Israel is deploying AI tools as part of its military arsenal. Skip. The public statements acknowledge that some of the targets attacked by the IDF are produced by AI tools. Skip. One encouraging aspect is that it seems that the IDF seeks to use tools that complement human decision-making rather than a substitute for the human factor. So here, this is a human in the loop, or a soldier basically in the loop, acting as a backstop to the decision, or to check the decision or the recommendation of the AI tool. The question is, how likely is it that this person or this soldier is actually doing due diligence? We saw earlier for the insurance claim that basically doctors are spending 1.2 seconds checking an insurance claim. So this is from The Guardian. And the point here I'm making is that having a human in the loop, a worker in the loop, is no panacea, because that human is subject to the same social forces that led to the creation of that AI system in the first place. And that AI system has a purpose, and the purpose is to be automated. It is not to be slowed down by, in this case, the human. So this is from a Guardian article in April 2024, sourced on six sources who worked with the Lavender system that the IDF was using in Gaza. We were constantly being pressured, bring us more targets. They really shouted at us. We were told now we have to F up Hamas no matter what the cost. At its peak, the system managed to generate 37,000 people as potential human targets. But the numbers changed all the time because it depends on where you set the bar on what a Hamas operative is. This is a system with many parameters. It has many knobs. So depending on where you set the knobs, which is something as engineers we always do, right? We're tweaking parameters for performance, in this case, for lethal targeting. So the numbers change all the time. So guess in which direction the numbers are going to be trending in such a situation. Now, who's going to vet 37,000 targets, or presumed targets? Skip to December 24. This is from a Washington Post story. Soldiers who were poorly trained in using the technology attacked human targets without corroborating Lavender's predictions at all. Lavender is the name of the system. At certain times, the only corroboration required was that the target was a male. So the point here is that if the worker in the loop, the soldier in the loop, and depending on how the scale of which the AI is being deployed, is basically useless. Even if that worker in the loop is a lawyer, there is a whole literature on so-called war lawyers, right? Some legal experts skip, harness the law in the service of the war effort. Now, the point being made in this book is not simply that the lawyers are like a cog in the machine, just basically giving blank checks to whoever wants to target. It's a more nuanced point than that. But the point is, it's a system as a whole that exists. And to go back to Alicia's point earlier, the ethical considerations don't start at the point after you've deployed the system and now you're seeing some results. The ethical considerations ought to come early on. And so no one can hide behind their hand and say, oh, I didn't see this coming. So, and I owe my thinking on this point to Zhanpei Feng, who's here in the audience, AI as a rhetorical tool. Sometimes the effective function of the use of AI can be to focus attention on the technology and away from how it's used, by whom, and to what ends. It's like, oh, are the AI's parameters correctly set? It's like, no, why is it being used? And this isn't a question one asks only about AI. One can ask it about just technology in general, right? But we're discussing AI here. Thank you.
Okay, so continuing on this problem of responsibility in AI systems, how many of you are familiar with the concept of a crumple zone? Excellent. This is so much different than a public talk. So, right, the crumple zone, lots of engineers, right? So the crumple zone, right, we know is meant to crumple so that the safety cage or where the passengers are is protected from the force of a collision, right? That's the point. The kinetic energy, right, is transformed into this like controlled crumpling, and it preserves the integrity. Mary Claire Elish argues that there's a similar thing that happens for workers in the loop or humans in the loop, where they are sort of the thing that's supposed to crumple in order to protect the integrity of the technological system, right? So they are the one that they're sort of like the fall guy in a sense. And this is a bit strange, right? It's weird because human actors who are involved in these systems tend to have very limited control and limited understanding of how the system works. But they're often this like sort of last line of defense, right? Where they're like, the buck stops here, I'm the last thing that can intervene. And humans in the loop or workers in the loop are often there because there are all these sorts of edge cases or modes of failure that are hard to predict or can't be ruled out. And so we need someone there to try to stop these different modes of failure. But as a result of being sort of the last one in the line of responsibility, is that the workers in the loop become this moral crumple zone where responsibility for the system is attributed to the human actor, who ultimately has limited control over the automated or autonomous system. Elish also describes this as liability sponges. Again, this sort of like absorbing the impact metaphor. One prominent example of this is in 2018, a self-driving car for Uber hit a pedestrian. The self-driving feature failed to detect the pedestrian, right? And the safety driver was intervened too late to stop the collision. However, it was only the driver that faced criminal legal charges as a result of this incident, and Uber did not, right? So we can see here the driver absorbing the legal impact of the death of the pedestrian, while the technological system, Uber did not face any sort of penalty. So there's a couple different problems with putting people in this role. So first is de-skilling. Increased automation leads to the atrophy of skills over time. This is why we require pilots to do so much flight simulation, right? Because no one wants a de-skilled pilot, but actually most of flying, right, is automated, is on autopilot. So once your skills have de-skilled, say you've got a doctor doing sort of a radiologist who's been reliant on a sort of MRI algorithm for years, we might worry that, their ability to sort of see and notice these sort of edge cases is going to get worse over time. The other thing is what they call the handoff problem. Maybe some of you are familiar with this, but this is the idea that you're sort of doing nothing, you're superfluous, and then all of a sudden you need to intervene in an emergency situation, or you need to notice a failure that the system has not notified you of, right? So in the case of the doctor with the MRI machine, you need to notice that the diagnoses or recommendations are somehow now inaccurate. In the case of self-driving cars, right, you're sitting there, you're not doing anything, but all of a sudden you need to sort of like debug in an emergency situation. And humans just aren't great at sort of like not having anything to do and then intervening in sort of like a crisis or high stakes situation. So this is one of the things where we put people in these situations where they're sort of psychologically not super, we just don't have great capacities for this. And the last thing is that people have a lot of trust in machines. My significant other always tells me not to trust Google Maps autonomously. You know, like always check the route first, because you might like know things or have different ways to think about the route that the map doesn't. But people tend to be like, oh wow, like look at all this math. Like surely it knows more than I can do. And so we're supposed to be having workers or people come in and bring context or expertise, but their deference to the machine that they think knows more than them makes it so that they might revisit their judgment or feel really scared to intervene when they don't have, say, like all the numbers. And so there's a social tendency to overestimate the capabilities of machines. So what's wrong with this from a philosophical perspective, not just like this is a labor perspective? This seems like a crappy situation to put workers in. The problem is that the existence of these moral crumple zones violates a basic moral principle about blameworthiness. And this is what in philosophy we call the control principle. Okay, so to give an example of how the control principle works, it's highly intuitive. Let's say you're on a bus and the bus driver brakes really hard and the person next to you has their coffee, you know, it's the morning, you're on your way to work, and their coffee spills all over your shirt. And you're like, oh God, now I have to go to work and I have like coffee-stained shirt. In this scenario, you might be like really bummed about your shirt being stained or ruined, but you are not gonna blame the person next to you, right? Because you're like, oh, well, it's not their fault that the coffee spilled, it was because the bus braked so aggressively. And maybe, I mean, depending on the scenario, you might not even blame the bus driver because they might not have been able to do otherwise as well, right? They had no control over the situation. Maybe they wanted to avoid a collision. But if you're like, whenever I teach this, my students are like, no, the person with the coffee mug should have had a better coffee mug, you know, like, who are these irresponsible people with their like coffee mugs that can spill on others? And even if you think that in this scenario, what you're really arguing about is about what sorts of actions are under your control, right? You're saying that the coffee mug person is blameworthy because they should have exerted more control than they did. Even though I think that's like kind of ridiculous in this scenario, we agree in the end, okay? So the control principle, right, is the idea that you should only be morally responsible for what's in your control. And there are like a bunch of reasons why we might intuitively accept this. I mean, if you've ever been blamed for something that your sibling did growing up, like you get the sense in which this is like unfair to be blamed for things that are not your fault. But it's also really unproductive, right? If you are blamed for things that are outside of your control, the thing that ultimately caused the problem or was the source of failure might not sort of be accountable or punished or sort of changed in the right sorts of ways, right? So when humans in the loop get blamed for errors of a technological system, it leads to sort of disruption of accountability, which might make us sort of less safe long term, but also is just unfair. So going back to our harms and wrongs, right? It's wrong and also a harm. So in conclusion, we've given this whole talk about AI ethics. And the note that we want to end on is actually, we should all be suspicious of ethics because it's not a panacea. Is anyone familiar with the phrase greenwashing? Greenwashing? Yeah, okay, so greenwashing is the idea that companies often take on this superficial sort of commitment to environmental action by, I don't know, putting some part of their product that's recyclable, or doing some sort of superficial change to change their sort of public image or avoid. Yeah, exactly. So ethics washing is something that we can also see in this sort of, is an analogous concept, and we see it a lot in this sort of hype cycle within AI, is this sort of practice of feigning or engaging with ethical considerations in a superficial way to sort of improve the perception of your organization, right? Or maybe to avoid regulation. Like, you don't need to regulate us, we're regulating ourselves. So in this example, right, OpenAI talks about being a leader in safety, about deepfakes and private information, even though, they're creating this text-to-video generator and text-to-voice generator that pose massive problems, right, for privacy and sort of fraud or things like that. So, I mean, it's a little bit weird to be like, we're the leader in safety, but also we're like heavily contributing to a certain type of problem. So the last thing I'll just say is one of the big things about sort of the failure of ethics in AI is that so often they sort of end up actually creating this sort of superficial reassurance while actually justifying the press forward for innovation or whatever. And part of that is because these sort of the various different ethical programs that are implemented are disconnected from power. So people don't actually have a ton of power over corporations, over researchers, over sort of decisions that get made. And so it's very hard to actually enforce or sort of change the status quo when there's giant power asymmetries between people and these forms of technology.
So we'll conclude on the following. It's a question that Alicia and I often enough ask, which is there anything new here? When we talk about ethics and AI, is this any different from ethics and automation or ethics and technology? And part of the reason that is a question is, one, the understandable conflation of AI and automation. So not all automation is AI. So some of the questions we are asking about ethics and AI are really about questions about ethics and automation more generally. So, who's going to lose their jobs, et cetera, that's been asked for the last 150 years. The understandable, or as Alicia pointed out, intentional sometimes confusion on what constitutes AI. Intentional in the sense that there is a lot of hype in this domain from people who want to sell products or who want to raise funds. So, you buy an LED and that's like a smart LED now. So again, some of the questions we ask about those systems, which one might debate whether it's AI or not, and I don't know how interesting that question even is, honestly. Is it AI or not? That also leads to a question of, well, what's new about ethics of AI? Then there is the theory-free ideal. I forget the name of the philosopher. Again, this is from Janpei's paper on AI being presented as this new, disruptive, unprecedented thing which is disconnected from the scientific endeavor as it preceded it, right? So it's so new that the ethical questions we're asking about it are de facto new. That's not a logical conclusion one can draw, I think, just on the face of it. Finally, well, what does it matter if the question is new or not? So suppose all of this is old hat, so what? In a sense, the questions still need to be asked and looked at. Thank you.
Thanks for listening. I hope you learned something about how philosophers and engineers are thinking about the topic of ethics in AI. This is just a small sample of what goes on here at Oregon State University in the area of AI, where we have a long history of research reaching back decades. More recently, Oregon State became the first institution in the country to offer both master's and doctoral degrees in AI. If you'd like to learn more, check out the bonus content on your podcast app or at engineeringoutloud.oregonstate.edu.